Am I audible, Zubair? Okay. So first of all,
Yeah, we
thanks.
can hear you.
Yeah, thanks for all the participants who joined here, and yeah. So today our topic is integration testing with MUnit and Docker. Okay. So here are some housekeeping rules. The session will be recorded. The recording and slides of this meetup will be available to all the attendees. Okay, please be muted during the speaker presentation. Questions can be asked at any time in the question and answers chat box. But at the end of the demo, there will be Q&A session. So give us feedback and at last. So today's agenda is introduction and how testing impact our developer productivity, and Docker Compose and component testing. Finally, demo with and Q&A. Okay. So meet our organizers. So my Mule, working with Bits and Glass India Private Limited as a senior integration lead, and Yogesh, he is a CEO for Mulecraft India Private Limited. Unfortunately, he couldn't join today. And Nagaraju is here with us today. So he is working in Plural site as a lead integration engineer. Okay. So please feel free to volunteer for the future Chennai meetup. So you can contact me through LinkedIn, or as you can send a mail also in this email ID. So this is about MuleSoft community. Training site is training.mulesoft.com. Anypoint platform is anypoint.mulesoft.com. For help, we can go to help.mulesoft.com. For becoming a speaker, leader, or mentor, you can approach me. Okay. Yeah. So our today's speaker is Zubair Aslam. He is a senior solution engineer in Docker. He's based out of Australia. So over to Zubair.
Yeah, thanks, Nini. If you don't mind, I'll start sharing
Yeah.
my screen and go from there. Yeah. So
Sure.
if you stop sharing,
Yep.
let me start where you left off. A lot. First of all, a quick thumbs up if you are able to see my screen, which should be the slide deck that you are sharing as well. Awesome.
Yes.
Thanks for that. First of all, listening me on your Saturday morning. That gives me some privilege, right? So you guys are able to join to listen into that. So thanks for that. Just as Lini mentioned, I'm Zubair, based out of Australia, Melbourne, where it is afternoon on a Saturday, but it's afternoon of a spring. As you can see from my background, the leaves are coming out and it's a beautiful weather. Right now, I'm in Melbourne, but the vibes are there. So just a little bit myself, around 20 years in industry. That should also for a very long time. I have been doing integration in microservices. I've seen the trajectory. Like we started off with EA, went into more of a software on service-oriented architecture, then and microservices. I was part of for close to 3 years, just till the end, start of last year. I was working as a solution engineer in Mule. Before that, if you guys are in integration for a reasonable time, you would know TIBCO as a product. Was part of that. Did a lot of work on that. I was one of the MuleSoft leader for Perth when I was based there. So MuleSoft meetups have a special place in my heart. I love those, and I love the community where people spend their own time and organize that. So big shout out for the organizer. I know it takes time and effort to do that. I have been MuleSoft instructor as well. I think that's enough about myself. Just moving quickly into where I am now. Like with Cloud Hub 2, as you know, we were moving into those containerization and Kubernetes sort of deployment for Mule applications itself. That was a big area of focus for me for last few years, cloud native architecture and design. And that led me to where I am now as part of the Docker, doing the pre-sales work at Docker as a solution engineer. But my focus nowadays is around developer experience. People call it different names. One of that is DevX, which sounds cool, so I use that name. And then developer productivity, right? That leads me into the session that I'm going to talk about. So what is developer productivity, why it is important, and what do we think about how we can make our developers more productive. So that's the focus for today. Moving on. So what is developer productivity? To start working within integration space, specifically around platform, the big promise is we want you to focus more of your energy in doing the actual development of the services rather than writing too many of the services or too much of code that is just related to integration. So MuleSoft platform give you the head start to do that. However, when actually developing an application, you want to do it as soon as possible with better quality as well. So what is going on as a developer, irrespective of which platform you are working on, you need to get a bit of a feedback from. So I'm developing a system API. I'm going to use that example throughout because that will just make it more consistent. So just assume I'm a backend developer. I'm developing an API that is supposed to bring in some data from a database, right? That's a system level API that I need to develop. Now, when I write get method, I want to be able to test it out that it is working fine, right? I want to reduce too many things in my head so that I'm totally focused on that. And I want to get into that flow state. So what is a flow state, so to say? Let me just explain by giving you an example, right? As a developer, what we normally do, we used to do that search like on Stack Overflow most of the time. If we are trying to write something new, then read a little bit, copy and paste, or write some code. Or in case of our MuleSoft platform, you just drag and drop. However, the right side of things is shrinking, right? Now we are getting a lot of help with AI. We'll be able to generate the code pretty fast. However, then we need to do the build. We still need to run the code. We need to make sure that it compiles fine, it gets built fine. We need to test it. What the code is really doing what it's supposed to do. In this case, get some data from a database, store some data like product API, for example. And then finally, when we are okay that it works, we do a commit to our source code repository. The more you can do in this inner loop, the better you would be able to deliver. Imagine now, I write some get method. I don't have a database to test against. What can I do? I have to commit my code, run it in CI/CD, then the application will get deployed. Then I'll be able to do some tests. But that takes away, like I'm focused now, but then there's a new thing that comes up and my focus will go away. And I'm sure many of you would have experienced this kind of work where you get into that flow state where your mind is now fully in developing, you get interrupted because of anything, right? Then you go back, then you pick it up again, then you get interrupted. And overall, the day passes and you say, okay, I'm not able to finish anything today. I don't know where the time has gone. Many of us as a developer, we have been there. The best for us would be once we get into that state, start our day, got through the coffee, morning chit chat, all good, stand up. Once we get in there, if we can reduce the interrupts, if we can reduce the what you can call as a context switch for us, we'll be able to get into that flow state and be able to deliver the APIs fast. Why? Because MuleSoft platform does it for us. A lot of it is done by MuleSoft platform. We just need to get into that right mindset and get through the job. Now, one of the major frustration as an integration developers, what we focus is our development platform is really good. It allows us to do things quick, but we are often slowed down by the dependencies. Now, I don't have the database to test against. I ask the DBA, they'll say, okay, I can't give you the username and password. You have to deploy your application, so on and so forth, right? And you guys all would have been in that space. Now, database is the simplest, but then you could be integrating with another API. You could be integrating with a messaging queue. You could be integrating with a cache system, anything, right? You have those dependencies. And more often than you are able to write your own code pretty quick, able to write all the transformations, but then you are stuck with the other systems once they're available, and that's where your flow state is gone. So that's the challenge that I talk about, how we can use containerization to solve that problem, how we can get some lightweight containers running on our own machine so that we don't have that external dependency. So that's where the industry is moving, where we are enabling our developers to do more on their local machine. How does that impact? Like, what is testing to start with? Now, if you see normally in your application, I'm pretty sure most of you are good developers, so you follow the best practices and you do write the unit tests. In case of MuleSoft platform, you write those MUnits. Then but MUnits, as you know of today, they are able to do quite a lot, but that is still restricted by, you can test your flows that are not dependent on the external entity. You're able to test a transformation, you're able to call and then mock it up. So a lot of time you have to do a bit of mocking, but you are able to test your own functionality. All the transformations you can test, any other logic that you have written, if else conditions, any of that you're able to test. In the middle, what you see is integration testing. So once you are done unit testing, then you want to do the integration testing. And that's where you want to actually connect to another system. You might run into some connectivity issues, both from the libraries that you are using might not be compatible with the other one. Then they agreed with a specific format that they are not passing that data in the specific format, all of those things. And on the top, once you are gone through, is the end-to-end testing. Like, this is where you actually add the data into one system. You want to see it flowing to other system, and all the integration test is done. Now, if you see how you can map it up, is your your unit testing implementation details. Like, that's where your conditional logic, that's where your transformation comes in. So that is something that is at the bottom. You see it here. That maps to your integration testing, your unit tests. Your integration tests are the ones that define your integration. And that's why I depicted it as the biggest chunk. As an integration developer, you would know that we spend a lot of time in integrating and in testing our our flow, if they are able to talk to the next system. If all of that is fine, then integrated testing is where all the systems are integrated. You add data in one, and then it will flow through. If you have done the things at the bottom right, this shouldn't take too much time. The only errors that you should be getting here are the data errors. So if the other system is supposed to pass in something and they are not passing in, that is a data problem. That's not your implementation problem. That's not the logic problem. That is only possible if you have done the other two things right. If you haven't done the integration testing, you haven't done the implementation detail testing, what you can end up is you deploy your API, and then you start to find out, okay, I can't connect to database because my driver is not right. I can't connect to that one. So you highly encouraged to do it in a right manner. By the way, I'll take a pause, and just if we see any questions in Q&A, just feel free to interrupt and ask as we are going, because we have a small group, so we should still be able to cover everything that I want to cover, but I want to make sure that people are getting their questions answered as we go. Now, just to, as I mentioned, just to recap, integration. So at the bottom, your unit tests, they are all about implementation detail. Integration test is where you should be able to test in a more isolated fashion. When I say isolated fashion, is you want to focus on your own integration points, your own interaction points. Have you done, we highly encourage when we are writing APIs to do the contract first. You agree on the contract. You just want to make sure that all of those details are there. You are still not doing end-to-end testing because you don't want to be reliant on the other system to perform because of the reasons that I mentioned at the end. That is not to say that you don't need to do end-to-end testing. You definitely do, but then you are kind of 90% sure that the work that you have done is a meaningful work. It is going to get passed, so you can even hand it off to QA, because that's where you are pretty sure that it's going to be a data problem if there is any problem. Now, combining the two, we talked about developer productivity, we talked about testing. Now, the reason that I talked about these two topics is how we can enable developers to do better testing so they are more productive and their developer experience is better. That's where we see the with how things are today. What we have today is, from the left, as I mentioned, you do write your MUnit tests, but then if your API is dependent on a database, your options. Either you install a database locally, which we all know is not easy, right? Depending upon which organization you are working, many of the regulated industries wouldn't allow you to just install whatever you want on your local machine. Even if you do that, then configuring the database and all of those things, it's a challenge on its own. And how many end systems you can install. There are some options of having some in-memory solutions for messaging queue and all that, but still not clean. We normally do a lot of time, we do mocks, right? We use Macrox or WireMock, but then you do a lot of work to make that thing work once, and then it's still a mock. It still doesn't give you that confidence that you are actually able to connect to a database. You are still making a database call but getting a mock response. You are making an API call but getting a mock response. We don't know how it is working. Another thing that I've seen quite a lot is shared instances. So you say, if you're connecting to a database for a product API, you might have a shared instance of that database that is a dev instance. So you are allowed to connect to that, you are allowed to test against that. But what we see often is it's an external dependency. First of all, you need to go get those username and password, get the connection string. You need to make sure you have the network connectivity all done. And if someone is moving new into your team, we know it takes weeks to get all those things sorted. So it's not efficient, number one. And number two, you might be jumping on each other's toes. What I mean is adding a row to a database, the other person is running a test to delete it from there, and you're just and kind of conflict situation. So while it is better than the first, it's still not the optimum solution. We have all done that. I'm pretty sure. With all those challenges, we don't test, we let it run in production. We definitely don't want to do that, right? That is, unfortunately, gets done, but we don't want to do that. We want to do the proper testing before going anywhere near the production, right? So that brings me to the topic, how you can do that with something called Docker Compose. I'm pretty sure you would have heard of Docker. Being in the integration space specific developer, you would have heard that. So Docker allows us to containerize your external dependencies and run them on your local machine. So you are able to run the tests end to end without those dependencies or those inefficiencies that I talked about. So that's what I'm going to show you today, how you can do that. Now, this is a depiction of how it can be done, or how it is done, sorry. On your, imagine that's your developer machine. I love MacBook, so I assume it's a Mac, but it could be a Windows machine as well, right? Any machine. You have your Anypoint Studio installed on your own machine, and then you are writing your code. Obviously, you have your flows, but you have also written MUnits to test that API. Today, if your API is connecting to a database, what you have to do is then mock it up. But with this newer approach, if you have Docker desktop installed on your machine, what you are able to do is spin up a container of MySQL. As an example, all other databases are containerized as well. Run it up here, and then run your unit test against this container as an actual dependencies rather than mocking it up. So you don't have to wait for anything. You don't have to ask for a shared instance. This database will spin up as you run your tests, and then you can spin it down. You are done. The good part about this approach is, I'll just go back one slide, two slides. You can then run those tests as part of your CI/CD platform as well. Because it's the same thing. Once you are running over there, your MUnit tests. So today, when your MUnits are just about the implementation detail. But with this approach, even in your CI/CD, they will be able to run the tests with an actual dependency, as I mentioned. But you are able to do it on your own machine as well. That takes me to the demonstration part of it. So what I'm going to show you a few things. First of all, I'll show you one sample API in MuleSoft, Anypoint Studio, just an implementation part of it, what that API is doing. Then I'll show you some MUnit tests that are written against that. I'll then show you a file that's called Docker Compose file that you can run that to spin up a database locally. And then we'll run those MUnit tests and we'll see how we are able to test against the actual database. So if you don't have any questions, I'll go ahead and I will start sharing another screen, which would be my Anypoint Studio. Dini, can you please confirm there are no questions? I'm not able to see the chat. I do see something in Q&A. Is there a question?
Yes, we have question from Edward Eptimo. Edward, would you like to speak out? You can unmute and speak. Yes. Edward, you're not audible. Yeah, please.
Can you hear me?
Yes.
Yes, we can.
Whether yes, it's just to figure out whether it is really suitable to use Dockers instead of in-memory setup and tear down when you fire your database, message-oriented middleware, and other components directly in your operating systems, and just use the real components instead of mock, and just trying to figure out whether the overhead of firing Dockers is actually worth spending efforts when comparing to this setup with the memory setup and tear down and configuration.
So Edward, if I got your question right, this is about comparing this approach versus an in-memory database or in-memory messaging queue. Is that right?
Well, it's very limited, but it is more or less this. Yes, it's comparing and rather giving the color to the advantages that will be really overcoming the complexity of having Docker infrastructure and overhead on your laptop instead of having a small, nice, easy JVM.
Yeah, okay. So so you made a bit of assumption there that Docker setup is going to be a lot. So nowadays, I'm not sure if you are already using Docker desktop on your local machine, but something that I see very common as a developer, even before that, was you would have, I would call it out, Postman, your IDE, which is MuleSoft, and Docker. These are kind of few developer tools that you would see in most of the machines. Now, if you're not using the latest version, you might have some performance things, but in their latest version, they are pretty good. Number one. Number second is, let me get into the demo. I'll show you what exactly you need to do to be able to spin up a database, which is a simple example. And then we'll see how hard or how complex you think that would be. In terms of the overhead, in all honesty, I don't have any stats to share with you, like with Docker, this would be X amount of memory and CPU. With in-memory database, it is Y or Z. However, at a very high level, you're still running something on your local machine. So even for the in-memory databases and all, there would be some overhead. However, the biggest thing is it's not apple to apple. When what you are comparing is when you do against an actual SQL database later on, you can still run on that runs on my machine sort of a problem. With this one, it is more deterministic because you're actually spinning up our actual database. You're connecting with that database with the real library, and so to say, if that makes sense.
Yes, yes, I understand. Yes, that's well. I would say that that's a matter of opinion whether it is not really an overhead with the setup of Docker. That's maybe the point that I would like to discuss. But everything else, I agree with you.
Awesome. So Edward, let me get into that demo, and I'll also show you some another thing that you can probably install on your enable on your Docker desktop just to see what the overhead would look like. But let me get there. It's a good question. Let me go through the initial setup, and then I'll get back to this one, and then we can have a further discussion on that, if that's all right. So with that, let me jump in and start to share what I really wanted to, which is a window, which would be my Anypoint Studio. So, is that right or no? Are you guys able to see? Not really. Let me make it easier for myself. What I'm going to do is just share the entire screen, which is myself in a window. But you should be able to now see the Anypoint Studio. Is that right? Can someone come off mute? And
yes,
okay, awesome. So this is what I was talking about at the start. I have a API. I don't need to go into detail of this API. You guys are integration MuleSoft developers, so you would know. It follows the best practices. I picked these templates from MuleSoft template system level API, and I connected to a database. So it is doing all the usual good things that you get with your interface about get, post, and all those different endpoints. Then you have this implementation file where you are actually building. You are either doing a select, and then you are either doing a delete, and all of those implementation details, like you can see inserts, you can see some other details around the logic, right? But that's not the point. The point is here, now you have this API, you have written it, and you want to test it, right? As you are building this API, you wanted to test this API as you go. So one option obviously is to write MUnits. Now I'll go into the MUnits as well. And rather than actually calling the flows that are doing inserts, deletes, you only call the flows that are doing your transformations. Or you do some sort of mock exercise, and you write some code that is just there to be able to do the mock. Just want to clarify, not saying that that's not a good approach. You should definitely do that if you're not following this, something that I'm mentioning here, or Edward was mentioning about in-memory databases and in-memory messaging queue. If you're not doing that, you should at least do the implementation level testing of your flows. You shouldn't just leave it like this. So unit testing is a good approach, a best practice that you should follow. However, in this case, what I'm doing is I'm actually calling the flows. So like a get flow, an actual get flow that will just go ahead and do the call. So what it means is I need to see what I'm connecting to in this. When I run this test, what would I be able to connect? So if you see here, just to give you an idea, I'm just using the config, which is then pointing to one of the config files. So I'm getting these values in this case. Now, if I go into my settings file, in this case, I'm doing pretty sure using the dev properties. So if you see it's a local host, I'm connecting to a local host, and I should be able to be able to do that while connecting to a local instance. Now, if I come here and I do a test to this connection, it should fail. The reason behind that is because I don't have any local instance running. So what do I do? What are my options? As I said before, this is something might be new for some of you. What I've shown so far, it should be just something very common that you already know. What you see inside source test resources might be something new for you. So this is called Docker Compose file, which allows you to spin up your dependencies so that you can run the test. So nowadays, it's not hard. I have some links towards the end that you can follow to understand a little bit more about, depending upon where you are in terms of your containerization journey, learning of containerization, that is. You might be able to start with the basics of containers, or if you already know the containers, you might be able to directly jump onto Docker Compose, what it is. However, it's a simple YAML file. If I just talk about the first line is just the version, don't need to worry about that. Then we are saying we need some services. What are those services? I need a MySQL. I'll use the image. This image will come from Docker Hub. There are many images. We can talk about that in a minute as well. And then we'll say, once you take that image, create a container, just name it MySQL container 1. Yeah. And then you are providing some properties for that. Now you can see some username and passwords directly here. You can use some secrets. However, because it's a local instance, it's not something that I'm connecting to a shared instance and I'm exposing the credentials for that. So it's going to spin up on my local. It's going to shut down from there. Now, this is where we are saying expose this port to my machine. And then we are saying volume is because database needs some actual data to store. We are saying that this is my volume. And then what I'm doing is providing an initial SQL script to that database. So once that database spin up, it's going to create some tables and it will create some mock data for me so that I can run an actual test against that. That's pretty much it. However, what you can do is, if then you also have messaging server that dependent on, you can then go ahead and write another service. Say, I also need MQ, take an image for RabbitMQ, run it here. These are the credentials. Then you have a RabbitMQ running on your local as well. I need Redis cache. I don't know how many of you are developing against AWS services like S3, pretty common, something called local stack, similar to this image. You can then bring all of those AWS services, sorry, I shouldn't say all, but majority of those AWS services running on your local. You don't need to actually connect to a S3 service, for example. You have it on your local. I know this is a little bit new, so I'll give a couple of minutes, but as I said, you can then go back and read about it a little more. The other thing that I mentioned was this initial script to just load all the data in here, but this is not something, shouldn't be new. If you know your SQL, you should be able to see like it's just creating some table and then inserting the data. Nothing so specific about it. I need to go back here. Now, what I'm going to do is I'm going to jump in the terminal and run one command to actually bring this service up. So I'll go here. Let me clear this up. And what I can do, can someone come off mute and just give me a nod that you're able to see a terminal now?
Yes, we can.
Okay, awesome. So the command that I'm going to run is called Docker Compose up -d. Sorry, let me just show you where I am. I am in that same folder where I had my compose file. So if I do, you should be able to see I'm in my system API, and then I'm under the test and the resources. So when I am at that level, what I can do is go ahead and run a command, which is Docker Compose up, which will just bring all the services. In this case, there is only one service, but if I run this command, I should be able to bring all the other services up if I have most of them. So once I run this command, I should be able to see that my SQL container 1 is created and it is started. Now, how I can verify that is I can jump onto something called Docker Desktop. That is something that you need to have. If you want to run this kind of setup, you need to have Docker Desktop installed on your local machine. That's the only dependency that you need. Now, if you see here at the bottom, that's where I have just created. So this container has just come up now. If you'll be able to see, this just came up 26 seconds ago when I ran that command. What this container is a MySQL database with this image. I can talk a little bit more about what these images are in a minute. And this is exposed here, right, on 3306. This is all running on my machine. I don't have any external dependencies at this stage. I can go into this container and see a little bit more about it. If it is not working fine, where it is running, what are the other detail. But that's not the point of today's presentation. Today's presentation is more about how you can then use this container against your MUnits. So let me come back to my Anypoint Studio and to my global where I was with the system API. So now if I go ahead and do against this configuration, if I do the test, I should be able to, if demo gods are happy, I should be able to see the test connection is successful. Now I can just go ahead, cancel it out. And as you can see, I've run it once, but let me do one more time. Now I can come in here and I can go ahead and easily say, run this MUnit suite for me. What you should be able to see now is, because I have a database running, all my MUnit tests that are written would then be able to go ahead and query my database, add additional row, delete, or if you want to 404 for a row that is not there, you should be able to see that as well. So while it is getting compiled, if there is any question that we can take meanwhile, I'm happy.
There is a question from Maxim Kogan. So he was saying, like, in my experience, Docker or mock, the main issue is more often the freshness of the data or service version that the tests are running against. So let's say you are developing against an external DB where you do not have access to. You would be in charge of constantly updating the data used by the Docker container, which is another pipeline to take care of. I don't say it's bad, but it's an effort to be considered.
Yeah, so that's a good question. So that's where, if you see, while I was mentioning about MUnits being your implementation detail, your integration test being your test against like your own system in an isolated manner. When I said isolated, that was exactly it. So you want to make sure your database structure is changing. That's a different story. Your database structure is normally more consistent. That should remain same. However, you shouldn't be too worried about the data itself. Why I'm saying that is because the main purpose of this exercise is to be able to make sure that you are able to connect to that database, you are able to do the select query, you are able to delete, you are able to do all of that in an isolated manner. Now, from that point onward, what you are mentioning is more of an end-to-end testing. Like what happens against the actual data. But remember, if there is a failure against an actual data, that would more likely be a data problem. That wouldn't be your implementation problem, if you know what I mean, right? So if I've done my implementation testing right, I've done my integration testing right, the end-to-end testing, if it is failing, that would be ultimately either the source system or the target system that is not able to accept. I'm assuming that you are working against the proper contract first development lifecycle. If you have done the contract right, there shouldn't be those kind of issues. There would always be a data problem, but then that means you wouldn't have to change your code. It would be the data that needs to be fixed. So that's why this script, that shouldn't change that often, because you're not really worried about the data. You're more worried about the data structure, if that makes sense. Again, not to say that what you are mentioning is incorrect. What I'm saying is it's a different concern. Sorry, you came off mute. I think someone came off mute. Yeah.
Edward, do you want to speak?
No, just I wanted just to say that yes, the point of Maxim is actually very valid, and I would say that we have this as another element that contributes to my vision, that well, we require the virtualization on the desktop of developer, but the virtualization as a normal VM, when you have access to the VM, and you can put some tools like Knife5, for example, in order to pump the data. And it's like, well, what I wanted just to understand why I have this feeling that Docker is a solution that is actually, well, well, not inappropriate, but it is in the hole between VM and well, local setup and the memory. But well, it solves rarely a problem, but itself is actually quite difficult to, well, not difficult, it's a resource to set up, and you do not have a flexibility as if you have a VMware or kind of local VM. That's my point that I wanted just to clarify for myself.
Yeah, that's a good question again, and that's what we get a lot, like VM versus containers. VM is a virtualization platform as well. Containers are virtualization platform as well. It's all about the ease of use and how quickly you can get going. So, as I said, or for what I have shown you is what you need is Docker Desktop. That's installable. You can download and you can install pretty quick. There's not much, you don't need to read too much of documentation. It's a Windows or Mac installer. And then what you have in here is this compose file, right? Now, when I create a VM, that's a virtualization, but then I need to go ahead and install the SQL database on top of it myself, RabbitMQ on top of it myself, expose it out to my system, because remember, VM is a virtualization. Then you need to export the some of the ports to be able to connect to that VM itself, or the software that is running within the VM. So Edward, the key difference over there, two things: VMs, they are more resource intensive, they are bigger. Containers are much smaller compared to that. So that's where we have moved on. And to give you one example, specifically, if you know Docker Cloud Hub V1, that was all VMs. When you deploy an API, what we were doing behind the scenes, we were spinning up a EC2 instance, which was a VM for each API. This used to take a lot of time. If you remember, deploying an API on Cloud Hub used to take time because we were spinning up that VM behind the scenes. Needed a lot more resources and costly for us as well. That's why we always run that problem into minimum vCore is 1, because it's a whole VM that we need to run. With Cloud Hub v2.0, we are in a containerization world. When you spin up an API now, it gets spin up as a container within a pod. It's not a VM, whole of a VM anymore. This is again not to say that VMs don't have their own space. VM have their space, but containers are on top of VMs. They are much more efficient use of your resources compared to a VM. You can't run 5-6 VMs on a local developer machine, whereas you can easily run many containers. So just to give you an example, Edward, you did mention about resource usage once before as well, and this is where I wanted to get at. With Docker Desktop, you can install some extensions and see exactly how it is looking like, right? So at this stage, you can get to see, okay, what are the images that are on my machine? Most of the memory is taken by the image, not by the containers. As you can see, the containers that you are running, they are just taking 1.93 GB of your resources. But then you can also get into a little bit more details about the resource. These are the extensions. I have it on my machine. If I want to see where the things are going, I can have an exact look into what I have allowed it to use, what it is currently using, and if it is a problem. Yeah, but just to give you an example right now, I have this, how many containers? 1, 2, 3, 4, 5. I didn't want to go in there, but probably another 2 here and then another one here. So 7 or 8 different containers doing different things. They're all running. This is, by the way, pretty expensive in terms of the resources, I'm running Grafana on my own. So if I'm writing an API which is exporting to Grafana, I can even test that end to end. So just to recap, VM is a lot more resource intensive. They actually virtualize whole of your operating system. Containers use your operating system at the back end. They don't virtualize whole of the OS, but then they just virtualize the application layer. So that's why they are less resource intensive compared to VMs, if that makes sense. However, just to go back to the idea of this presentation, you do VMs, you do in memory. The cool thing should be that you should be able to do more testing locally without going. In my experience, I have in many organizations having that level of maturity where they are doing something about enabling their developers to do something locally. Docker Desktop, I find it the easiest way to get there. Yeah, just to recap some extensions that you can see about the resource usage and all that. I just quickly want to touch on one more thing that I would like to go on docker.com, and that's, Edward, to your question, not exactly the same question. However, just to give you an idea, like I go RabbitMQ, I should be able to see, I don't think that's the right one, but let me do local stack. I can come in here and start to see what is available. Like, for example, I come in here and I see them pulled by more than 500 times. What it does is I can just have a quick read about this image. So if you are developing against any backend system that you want to test, you should be able to come in here and see if the image is available for that, number one. If it is, then how you can bring it in is pretty easy, just by putting, this is the image that I want, and you should be able to bring that image. Now, how hard it would be with a VM, you need to know, you need to do the actual installation with a VM, for example, and then how resource intensive VMware running on a local machine would be. Again, I don't have the first-hand experience, but I assume it would be more complex than that. I'll take a pause. So where we were, sorry, you should be able to, as by now, you should be able to kind of see all of those unit tests that they run, and they were successful. 9 of them run. They were actually against the actual dependency. So most of the discussion today was more around the alternate, but the key thing is, are you able to run your unit test with the actual dependency, or you're spending a lot of time just mocking few things up, which doesn't give you still that confidence. I'll let you guys to, depending upon your own experience and expertise, which way you want to go, VM or in-memory DB or in-memory sources versus Docker Desktop. I think that's probably depending upon where you are within your organization. Pick one, but definitely start looking into this area of enabling your developers to be able to do more on their local machine with the end-to-end sort of testing. Edward, quickly checking in this regarding your resources question. Was it helpful, like some of those extensions that I mentioned, that if you are using Docker Desktop, you can install and have a look on those?
Oh yes, I will, for sure. I will try all this what I see, because yes, there are some elements that I did not use so far. Well, it just to say that yes, that's actually what I'm just trying to understand, or maybe to underline that you have two things that are either very resource demanding, less like firing VMs. You can do it with the background, and it's a little bit easier to set up with this technology. But in the other hand, if you have a smaller laptop, yeah, it's maybe, you know, a solution with in memory. So Docker is in between for me. So that's maybe the use case that I need maybe to explore a little bit more, and maybe I will find out with these additional plugins how to manage it better. But it just maybe my problem that I have I maybe to There are laptops that are like workstations with a lot of memory, and then that's the reason why I'm
100%.
sensible. Yes.
I just want to acknowledge that, Edward. And to be honest, I worked with MuleSoft for a long time, and this used to be a one-off objection as well. Like Anypoint Studio is very resource intensive, right? So sometimes there are some limitations that you need to work with. Today's presentation, I don't want to feel it look like more about the functionalities of Docker Desktop, but to your point, Edward, if you see on my screen now, this, and just to give you an idea, this is an actual kind of consideration, because our laptops are not always biggest memory, biggest resources. What Docker is doing as something is creating remote engines. So your experience would look like similar, but rather than running this DB on your local machine, what they'll be able to do is create it in cloud behind the scenes. But this is, again, I wanted to keep today is more at the starting level, where people start to think about how they can do more on their local machine before kind of going to the detail level concepts. I'm really happy to come in again in 4, 5, 6 months, where people reach out and say, want to go to that next level to talk about those remote engines as well. I'm conscious of time, just want to leave you with this resource. This system level API is available on GitHub under my repository. It's a public repo. All these details that I talked about are here. Most of it, as I mentioned, it's just coming from the template that is available on on MuleSoft Anypoint Exchange. I just copied it from there and added the instructions to be able to run it, how you can run it with Docker Compose quickly. Some of the prereqs that are required, how you can import it. Just follow along. If you feel like there are some like instructions that don't work as it is, let me know. Happy to update. But I'll definitely recommend you guys just have a play around with it and see how you go from there. That's it from my side. I'll hand back to the guys, especially Lini, to wrap us up. But these are the resources. Have a look on these GitHub repo I just mentioned. You can download Docker Desktop, and you can learn about Compose and containerization too, if you want to start from there. Lini, over to you. And special thanks to all the guys who have asked questions. We don't want to have a session where people are not interacting. This is where we learn from each other a lot. So thanks everyone who asked questions. Thanks to the ones that didn't ask questions, but they were listening in with intent. Thank you.
Yeah. Thank you so much, Zubair, for an informative session. So in future also we'll plan some sessions. So I thank all the participants for their valuable participation, and yeah, especially for Edward for active participation here. Yeah, thank you everyone. So any questions, anyone? I think no. Yeah, so we can wind up. Thank you everyone. Thank you all. Bye. Yeah. Thank you, Zubair.
Thanks everyone. Bye for now.
Bye.